Welcome back to AI Path. In this video, we're going deep into NemoClaw's 4 security layers. This is the core of what makes NemoClaw enterprise ready. We'll look at network, file system, process, and inference policies, plus the actual YAML policy format. Let's start with an overview. NemoClaw enforces security at 4 layers. Think of them as concentric rings of protection. The outermost ring is network. This controls what the agent can reach on the internet. Next is file system. This controls what files the agent can read and write. Then process. This blocks privilege escalation and dangerous system calls. And finally inference. This controls which AI models the agent can call. 2 of these layers are hot-reloadable, meaning you can change them while the agent is running. 2 are locked at sandbox creation time for maximum security. Let's dive into the network layer. This is the most critical one. By default, NemoClaw denies all outbound network connections. The agent literally cannot reach any server unless you explicitly whitelist it. You define allowed endpoints in the YAML policy file. NemoClaw ships with presets for common services. The PyPI preset lets the agent install Python packages. The Docker Hub preset lets it pull container images. The Slack and Jira presets let it integrate with those tools. Under the hood, this uses Linux network namespaces. And here's the key feature: if the agent tries to reach an unlisted host, the request is blocked and surfaces in the operator TUI for human review. You can approve it as a dynamic, session-only rule, or deny it. Layer 2, File System. This is straightforward but critical. The agent can only read and write inside 2 directories, /sandbox and /tmp. Everything else on the host system is invisible to the agent. Your system configs, credentials, other users' data, all inaccessible. This is enforced by Landlock, a Linux security module. Unlike the network layer, file system policy is locked at sandbox creation time. You can't relax it while the agent is running. That's by design. Layer 3, Process Security. This prevents the agent from doing anything dangerous at the operating system level. It blocks privilege escalation, the agent can't become root. It filters dangerous system calls using seccomp, the same technology Docker uses internally. No installing kernel modules, no raw socket access, no container escapes. Like file system, this is locked at sandbox creation time. Layer 4, Inference. This is unique to NemoClaw. All AI model API calls from inside the sandbox are rerouted through the OpenShell gateway. The agent cannot call arbitrary AI endpoints. By default, inference goes to NVIDIA's Ep.3 Super, a 120 billion parameter model, via the NVIDIA Endpoint API. This means no surprise API costs from the agent calling expensive models. No data leaking to unauthorized model providers. Local inference using Ultima or VLLM is experimental but on the roadmap. This layer is hot-reloadable, you can switch models without restarting the sandbox. Now let's look at the policy file itself. All security rules are defined in a single YAML file, OpenClawSandbox.yaml, inside the NemoClaw Blueprint Policies folder. You can configure policies in 2 ways. Static policies, edit the YAML and rerun NemoClaw onboard. These persist across sandbox restarts. Dynamic policies, use the OpenShell policy set command. These only last for the current session. This 2-tier approach lets security teams set baseline rules while operators can make temporary adjustments during a session. That's the full security architecture. 4 layers, declarative YAML, and a human-in-the-loop approval system. In the next video, we'll look at real enterprise use cases and how teams are planning to deploy NemoClaw in production. See you there.